Our project was basically seeing what chemical kills ants fastest, and we had found out that cypermethrin with bifenthrin had killed
the ants the fastest out of the ones we tested.
Within almost 24 hours, all ants were curled up, and in like 4 days they were all dead. And the other chemicals that we had tried had taken was indoxacarb and hydromethanol, and they had taken a day to 7 days to have officially.
They were curled up within a few hours, and it took 7 days to fold.
I was testing a horse's heart rate to see if a trot or a lope would raise it fast or raise it higher, and my conclusion was that a lope raises a horse's heart rate higher than a trot. I wanted to help the equestrian community with anybody that has a horse heart problems to keep their heart rates down.
In this experiment, I was testing to see which equine bedding was the most absorbent, because that can help horses in their stalls. They have different types of beddings, and that can help with their feet, and it just absorbs their pee. My inspiration was actually my horse. He pees a lot in his stall, and I don't want him to have a wet stall because that is bad for their feet, and it's just what's healthiest for the horse. So my conclusion was that the pelletized pine pellet was the best, most absorbent.
It is a homemade solar panel that's easy to use.
Que genera 12 volts aproximadamente. Puede encender una bombilla, descargar un teléfono, un motor, encender un motor.
So it generates about 12 watts of energy, and it can charge a cell phone, it can charge a small motor, it can charge a light bulb.
Puede cargar el teléfono aproximadamente entre 1 a 2 horas.
So it can charge the phone 1 to 2 hours. ¿Y qué son los materiales que usan?
Los materiales son DVDs, papel de aluminio y 2 cables de un positivo y un negativo.
So the materials that he used were aluminum foil and DVDs and 2 wires, 2 cables, a positive and a negative.
Entonces con este proyecto yo le demuestro a las personas que se puede crear algo que no se gasta dinero ni tampoco se contamina.
So what he's hoping to show people is that with this project you can generate energy without it costing a lot and without hurting the environment.
So basically what I made was a potato battery. It worked, it powered the LED light, it also produced 0.49 volts exactly. I think it would be enough. If you made enough of them, you could probably power a small thing such as a toy car. I used Google and the wiki for my information. My mom made this project when she was little, so I thought I would do it for myself since it looked pretty interesting.
The purpose of this project is to find out which paper towel brand is the strongest. The spirit will be performed 3 times to determine which brand of paper towel is the strongest. My hypothesis is if a specific brand of paper towel holds the most weight, then it would be based on the experiment, tested based on how many marbles on the paper towel before it breaks. The results here, Viva. I want to see which paper towel is strongest.
So that was the fact we didn't see. And you just go ahead and see now each trial.
So this year we have representation from 21 different schools, and we have approximately 160 students participating in the fair. The students that are selected for the State Science and Engineering Fair will attend a 3-day fair in Lakeland, Florida. And they will be presenting to our judges up in Lakeland. So we're extremely lucky here in St. Lucie County to have a multitude of CTE programs and magnet schools that provide a wide variety of STEM programs to our students. So it's really helped us expand the category representation. So we are starting to see more mathematics and engineering projects thanks to those magnet schools and CTE programs.
My project is on making voltaic cells, and it coincides with voltage. I used an ice tray, nails, and copper wire to make a galvanic bridge and to test the voltage of vinegar, lemon juice, and salt water, and to see if they could light up a light bulb. I also used a multimeter to test the voltage. My original hypothesis was that the salt water would produce the greatest voltage because of the sodium and chlorine ions. However, the experiment did show me that the vinegar was able to produce the highest greatest of voltage. And I was able to learn a lot of cool facts and research and about the background of the project, and it was a really fun project to do in general. Mostly my gifted science class, we were learning about the pH scale. Acids and bases were a part of that, and I thought that they were really cool how they can all conduct electricity. And so I decided to do some research on that, and I decided to further and make my project about that.
The question that my project is trying to answer is, what frozen dessert melts slower? Ice cream, frozen yogurt, or Italian ice? My hypothesis in the beginning was, if ice cream, frozen yogurt, and Italian ice are all placed outside, then the ice cream will take the longest to completely melt. The variables I have, my independent are the Italian ice cream, and frozen yogurt. My dependent is the minutes it takes for them to melt. My controls are the temperature, the amount, and the flavor of the ice cream, Italian ice, or frozen yogurt. The frozen yogurt on average took the longest.
Well, I'm just trying to answer the question, which liquid is best used for electrolytes in sports? And what I did was I used Gatorade, orange juice, and filtered water, and I attached it to I used a conductivity sensor, which is a straw and a copper wire, and I attached it to a multimeter and a 9-volt battery so I can get the charge. And I used the conductivity sensor and I measured the amperes, and since the amount of amperes is so small, I had to bring it to milliamps, and I found out that orange juice was the biggest, the most milliamps, which didn't support my hypothesis because I thought Gatorade was the one with the most electrolytes. And so what I did after I found my milliamps was I used a equation which I would have the conductance is equal to my current divided by the amount of voltage, and I ended up bringing it to amperes, and then after that I divided the amount of amperes and divided it to 9 volts because that's the kind of battery I used. Since I play soccer for a local club, I just wanted to, it was really interesting to me because I drink Gatorade a lot, and it's, it's really used a lot in sports.
So the project that I chose was what person keeps coffee pots over a 30-minute period. The 3 mugs that I chose were ceramic, glass, and stainless steel. The starting temperature for all 3 of those was 160 degrees, 0.2 Fahrenheit. So my hypothesis was that I believe the stainless steel would have the hottest temperature over the 30-minute period. So as you look at the chart, at the starting temperature 160.2 degrees Fahrenheit and the ending temperature 110 degrees Fahrenheit. The ceramic mug had an ending temperature of 100 degrees and the glass mug had an ending temperature of 106 degrees. So in conclusion, the stainless steel mug had the hottest temperature and and the ceramic mug had the lowest temperature over the 30-minute period.
And for my project, I chose which water will have the lowest total dissolved solids compared to still. And my hypothesis was that the Pure Life water was going to be the cleanest. And I was wrong because it was spring water. But first I poured like each water from each beaker into the ultrameter, which is a tool from the water plant. And I calculated the conductivity and I divided it by 1.7 to find the amount of total dissolved solids. And then that led me to finding the results. And spring water is the cleanest. So if you were to drink any water, it would be the best for spring water. My uncle works at the water plant, so it was a cool idea to do, and I got to go in the lab and do everything. So that's
Yeah, so it's my first year as a judge. I was more nervous than them at the beginning, but I think it's impressive how like the kids can like come up with all of these like research topics and like they know what they are talking about. And I don't know, I feel it's very, I never did this in my high school or my school, so putting them on this spot right now to have to present to people and like have to choose a topic of research, I think it's very helpful for them. Yeah, I mean, if they already got experience, I guess they will do it like much better. But like I saw impressive projects that it will have like for me like a grad school level even. Yeah, so it was very nice. Yeah, seriously, I was super impressed there. But yeah.
My project was on which filtration material has the best effect on drinking water. What I did was I took 3 cups of water and I put no food coloring, 2 drops of food coloring, and 5 drops of food coloring. What I did was I took 3 separate cups. I took 4 coffee filters. I put them on the cups. I took grounded charcoal. I put it in there, and then what number 1 did, it leaked the brown coffee filters. It bled into the water. It turned it brown. Cup 2 had the most effect. It got more clear. Cup 5 had no effect at all. My inspiration was I have a military family, and when my mom was in Panama, she didn't have that much resources to clean water. So I wanted to do something kind of related to that, and so it could be more cleaner and stuff.
Okay, so the title of our project is called How Effective is Allopathic Medicine versus Homeopathic Medicine? And actually, a lot of people use homeopathic medicine to this day. It's when you either have a sore throat or an upset stomach, and you drink tea, and some people put spices in their tea like garlic or honey, anything like that. Homeopathic medicine doesn't actually get to the root of the problem like allopathic medicine. Homeopathic medicine builds up the immune system, so the immune system can then take over from there and deal with the certain problem. And most importantly and most specifically, we are using homeopathic medicine and allopathic medicine for yeast infections. And yeast infections can occur in both men and women, but for this type of project, we are looking for yeast infections for women. And there is a perfect balance between yeast and bacteria. And the main hormone inside of women, estrogen, creates a certain type of bacteria called lactobacillus, and this type of bacteria helps get rid of any unwanted organisms. But however, when this balance is thrown off course or anything, this can be caused to birth control or sexual orientation or certain soaps. This can cause the creation of a certain bacteria called Candida, and this bacteria, this overgrowth of this fungus, is actually what causes yeast infection. And so to test our hypothesis, it is if we use allopathic medicine against yeast infections, then it would inhibit the most growth of yeast cells rather than homeopathic medicine. And to test our hypothesis, we conducted our experiment.
So for our experiment, we used a Kirby-Bauer test, which uses filter papers, and on those filter papers, we put our medicines. So after we prepared our petri dishes, we put them in an incubator, and we put them over there for 96 hours. And after that, we were able to take out our petri dishes and see our results. Our results did agree with our hypothesis, and as you can see in our pictures in our table, the allopathic medicines, the teoconazole and monostat 7, did prevent the largest zone at 2.5 centimeters and 3.5 centimeters, and our homeopathic medicine, boric acid and sepia, had the smaller zone of inhibition at 0.9 centimeters and 2 centimeters. And these two petri dishes are our controls, which is just our yeast and a blank plate.
Yes, and so the zone of inhibition shows where the yeast cells did not grow. It grew everywhere else besides this zone right here. And our hypothesis, like Sebastian said, was supported, and the allopathic medicine, the teoconazole and the monostat, did work better than the homeopathic medicine. And actually, a lot of people think that boric acid is good for you, but boric acid alone is not really good for the human body. It's the boric acid depositories that is used as the medicine. And we obviously couldn't culture the bacteria that is in the human body, so we used baker's yeast, which kind of is to emulate the bacteria that you would find in yeast infections.
So my project was testing the best methods to cleansing your hands in the school atmosphere. And my hypothesis was that hand bacterial wipes were going to work most effectively in getting rid of bacteria, because the purpose of bacterial hand sanitizers is removing the most amount of bacteria from your hands. And my findings were wrong, but simple washing your hands and the use of antibacterial spray are the best methods to keeping your hands clean, mainly because when you're washing, you are taking more time and being more precise with the soap. And then when spray, it is mainly because of the ethanol concentration in the antibacterial. The inspiration was actually off of social media on TikTok. I found a guy who tested if boys or girls have dirtier hands by swabbing their hands, and then when COVID hit, I thought it would be interesting to figure out which hand sanitizer method would be the best. Antibacterial spray or washing your hands.
My project is about the effectiveness of bacteriophage in fighting human bacterial diseases. Bacteriophage is a naturally occurring combatant of bacteria, which doesn't naturally occur in humans, but does naturally occur in plants. So it actually comes from the Greek word for to devour, which is exactly what it does. It implants itself in bacteria, devours it, where it shortly dies, and then regenerates rapidly. So I was wondering if this was possible in the fighting of human bacterial diseases like strep throat, E. coli, stuff like that. So I tested this, and in my results, I didn't get the results that I wanted. There was less growth on the plates, however, it wasn't completely eradicated. So I do suspect an error in my procedure, and next year I will be continuing the project with higher quantities of bacteriophage and with different strains of bacteria other than E. coli, because I do believe that this could be a very big advancement in medical research, and that bacteriophage could prevent strands becoming resistant to antibiotics. It could end up overtaking antibiotics in the medical field, and I believe that it could present sepsis and subsequent death from bacterial infections. My mother and brother were both diagnosed with similar diseases, and I remember being a child being quite scared for them. And I remember the relief I got when the doctors told me, I know what's wrong with your mother, I know what's wrong with your brother, they're gonna be okay. And I wanna give that same relief to other families.
My project is it's called When Equations Predict the Future. I couldn't fit the whole thing. It's called When Equations Predict the Future Crystal Ball Math, but I couldn't fit that on the slide, which is unfortunate. But so basically the whole point, I suppose, of my project was to see how the human population would behave when it's simulated using these two equations down here. I don't know if you could see those on the camera, but they were built by two English, there was one English and one French mathematician in the 1800s that is used to predict the population growth of any animal, not just humans, but we used it for I used it for humans in this specific scenario, and so the I sort of predicted that the first group, which has a carrying capacity, is the sort of main thing that I focused on here. So the first group has a carrying capacity of 5 billion, and I predicted that that group would sort of just like decline continuously until it reached 5 billion. I predicted that the 8 billion group would just sort of hover around 8 billion pretty much the whole time, which was the second one. And then the third group had 64 billion people as a carrying capacity, which I predicted would sort of just grow exponentially pretty much until it hit 64 billion. It never actually ended up hitting 64 billion though, because the rate of growth was a lot slower than I had originally anticipated. But the other hypotheses largely stood up with the data. They largely lined up with what I had. Excuse me. So the 5 billion. I admit the rate of all of these changes. Obviously, we knew that the control group, which was the one without any carrying capacity, so that's no limits on the growth. Obviously, that one was pretty much just going to go out of control. But the other three, I think, grew a lot slower than I originally anticipated. But if I had done this maybe over a longer period of time, potentially I would have been able to see if my hypotheses would have been able to better hold up. Like 64 billion, maybe if I had done this simulation over about a span of maybe 400, 500 years, I would have seen it hit the 64 billion mark, or somewhere close to there. That's pretty much just a brief overview of what I had done here. Well, I had originally planned on doing a project that was something like, with cybersecurity, but then I came to the unfortunate realization that I can't code. So I was pretty much stuck for ideas until a day before the project idea had to be submitted. So I found this online. I don't exactly remember where, but it was a really great idea, and I'd especially liked it because at this time the human population hadn't reached 8 billion yet, but it was getting pretty close. So I figured I could just work with the 8 billion number, since that's a really nice number to work with, and so it all kind of worked out perfectly.
Well, once again, I am blown away by the quality of the products and the projects that our students have presented at this science fair. Even with the impact of missing a couple of years because of the COVID pandemic, the kids their brains have stayed active and fulfilling, and everything they presented here. I had 6 projects that I was judging, but have gotten around to about 12 altogether, just because the topics are so engaging and the kids really want to share what they've learned. So it's a positive experience once again. More critical thinking is involved in the projects, I think now, more innovation in the projects. It's not so much, putting Mentos in a Coke bottle anymore. There's really a lot of innovation and thought behind this, and they're making it personal. I was talking with one young lady about, she came up with a thought for her project when she was home because of hurricane closures. And what happened if I don't have potable water? How could I do that? So her experiment grew from that. So they're integrating what is personal to them and what is impacting their daily lives. And it's really rewarding. Great hope for the future.
I've been very impressed with the passion that the students have had for their project idea and topic, the research that's gone into it, and their ability to execute the actual research and the experiment itself, as well as share the data. So it's been really quite interesting to see them and just listen to the wonderful things that they're learning. I think just overall, they year after year take a more vested interest in it, and it really drives how they approach their project, what they put into it, and their efforts. And so I really see that year after year, I think they're coming more prepared, more equipped to really take it to the next level at the state.
I did was I made a contraption that would launch the ping pong ball at 3 different angles, and I would measure the distance and the time it took to reach the ground, and I would use that to calculate the horizontal speed in the x direction. And using that and an equation and using math, I would calculate the peak height by resolving vectors and using trigonometry, and I would compare them between the 3 angles. And my hypothesis was that the 60-degree angle would reach the highest peak height because as you go up in angle, the horizontal velocity slows down, but the vertical velocity gets higher. So, and my hypothesis was actually right, as the 60-degree angle did reach the highest peak height on an average, and the trends were right because, as you see, the average would go up. But there are some inconsistencies in the project that I would try to fix by maybe making a better contraption and doing it inside to limit air resistance. I like math and science, and I like how you can predict stuff in math. So that's why I tried to use math to try and predict it and see the patterns in between everything.
Okay, so for my project, I was trying to turn heat into electricity using a thermocouple. So basically, I was measuring like different temperatures in order to see at which temperature would generate the most electricity. And so I measured it using ice water, boiling water in the refrigerator, and also in the oven, with the oven at like 250 degrees Fahrenheit and the boiling water 97 degrees Fahrenheit, 4 degrees Celsius for ice water, and also for the refrigerator at 10 degrees Celsius. And so basically I was trying to measure like how the temperature difference would create more electricity through the thermocouple. And so basically as the electricity traveled through the thermocouple, it would generate a meter reading. So basically at higher temperatures, it would generate more electricity because at a greater temperature difference, because at a higher temperature and at the basic room temperature, it would generate more electrons for more energy to travel through the thermocouple. And so the junction temperature would be lower if it generated more electricity, and it would be higher if it generated less electricity. And basically at the end of my research, I found out that at the oven, which is at the highest temperature, generated more electricity because at the higher the temperature, it created more electrons for it to travel through the entire wire into the meter reading. And so basically that's how I found out that with thermal electricity, with the temperature difference, it basically helps you to create electricity through different means, such as you could also make electricity like fossil fuels. It also has a heat difference, but like with fossil fuels, it creates more waste into the environment. But using just heat and to create electricity is more a greener solution to make powering different things like power plants, like houses and stuff like that. My inspiration for it is that I was learning about how energy is generated in engineering class, and I was learning about different ways to create energy and how it flows like a circuit. And then I was talking to my engineering teacher, and he had talked to me about using heat to make electricity because it's a new alternative to making electricity. It's sometimes they use solar panels or water to make electricity, but with this, they just basically use heat expelled from other substances like nuclear power plants. They produce heat through waste, but also using that waste to create new forms of electricity.
I did my project on what was the best way to root a tree cutting, where I found out that honey ended up growing the most roots over a week. So what I started off with was getting 3 cuttings from my Jamaican strawberry tree and stripping off the end of the stem, and then applying honey, rooting hormone, and then having one with nothing as my control group, and placing each one in its own individual pot. And so I watered them daily with about a 1/4 cup of water because they loved the water, and left that outside for a week, watering it every day. And after a week, I carefully broke apart the soil and counted the hair roots. Since they're super delicate, I needed to be extremely careful. The honey ended up growing 12 hair roots, while the hormone only ended up growing 7, with the control group being of nothing, growing only 5. Me and my mom love gardening and getting tree cuttings and growing them or giving them away to friends who may want trees of that cutting. And so our inspiration was, since rooting hormone's expensive and so is food nowadays in the normal market, people could start growing their own fruit trees with stuff they may have at home, like the honey, and just getting a tree cutting from maybe their neighbor or a friend, like how we do.
Alright, so my project was, how does mass affect different adhesives? What I kind of did was I wanted to see which type of glue or tape would hold the longest. So I did a little experiment. Of course, I did safety procedures, but I did find out that glue, the super glue, held the longest, and it actually has chemical in it that is what kind of creates a bond between two objects. It's called cyanoacrylate. Well, a lot of my family is in construction, and they do use a lot of different adhesives, whether it's wood glue or different things, and I'm like, so I wondered, well, how would it do with extra weight? So I kind of used fishing weights to add on weight and see how it held up.